Hello, this is Dr. Oz. Today I would like to solve Wealth mutual fund problem. In the problem, if you remember, we had 5 investment alternatives and we had 5 different constraints and we are trying to maximize our total return. All right, so let's get started with given information. These are the given parameters in this model. First of all, we have five investment options in this model. We could have more in real life. Again, I could use the same model. Atlantic Oil, Pacific Oil, Midwest Steel, Harbor Steel, and government bonds. All right, so we projected the annual returns for these 5 alternatives, annual projected returns. Projected return investments or returns. For investment option 1 is 0.073, which is 7.3%. Pacific Oil 0.103, 10.3%. For Midwest Steel 0.064, 6.4%. For Harbor Steel 0.075, 7.5%. And finally for government bonds 0.045, which is 4.5%. All right, so let's just pull this down. Perfect. All right, so I can make them percentage by clicking on percent icon, and I can increase decimals here. Perfect. Also, we have given available funds. We have $100,000 to invest. We have oil maximum investment amount, which is $50,000. And we have the same number for steel maximum investment amount, which is $50,000. And Pacific Oil is risky, so we have maximum constraint here, maximum of total oil industry invested, which is given to be 0.6, in other words, 60%. And we have government bonds, minimum of steel industry. We need to invest at least 25% of what we invest in steel industry, 0.25. All right, so that's all that we have in this model for us to as parameters. So let's build our model here. Let's start with the objective function. Objective in this model is maximize total return. All right, I will color this green. And let's define our decision variables. In this case, I have 5 different decision variables. How much basically money to invest in each alternative. Let me just copy these names. and I'm trying to dollar invested, figuring out dollar invested for these 5 decision alternatives. I will make them yellow. Excel solver will calculate those values for me. Now I can calculate my maximum return in terms of the dollars invested, which is decision variables, by some product. These are the returns that I'm getting for each product, array number 1 coefficients times the variables, and I will add them up. Perfect. Currently I'm making $0, but once I start investing money, I will start making money. Just give some space here. All right, so third is the constraints. And as we discussed in previous videos, constraints have 3 components: left-hand side values. In general, they are given, they're calculated, versus the relationships. And right-hand side values are in general given values. All right, so I have 5 constraints here. And their right-hand side values are given right here. You can drag it down to copy the formula. The relationships I need to define. So available funds, I have to spend every single penny. So it's equality constraint. Oil industry cannot be invested more than 50,000. So maximum is 50, less than or equal to. Same thing here, less than or equal to. So here, these are percentages. And I cannot go more than 60% of my oil industry into Pacific Oil, less than or equal to. And this is a greater than or equal to, because I need to spend at least 25% of my steel investment into government bonds. So let's calculate left-hand side values. Available funds, $100,000 can be invested by all 5 alternatives. So I will add them up. All right, this is a dollar figure. And oil max should not be more than 50,000. So when I add my oil investments, they should not be more than 50,000. Dollar figure 2. And same thing for steel. When I invest in steel, this Midwest plus Hubbard steel should not be greater than 50,000. Pacific Oil investment, which is right here, should be less than or equal to 60% of what? So we need to figure that out, right? So this value right here should be less than or equal to 60% of oil investment. So this plus this. All right, this is a dollar figure now. And similarly, government bond invested should be greater than 25% of steel investments. So times total steel investments is Midwest steel invested plus invested in Hubbard steel. Perfect. And of course, I have, these are dollars. And of course, I have non-negativity constraints. So if I just highlight these, color them red. Now, if I run my model, data, solver, my objective function value is right here. It's a maximization problem. My decision variables are these values right here. I can add my constraints. First constraint is an equality constraint. Left-hand side values right here is equal to, right-hand side values right here. Add. My second set of constraints include 3 constraints. These 3 should be less than or equal to their corresponding these 3 right-hand side values. Add. Finally, this constraint should be left-hand side value should be greater than or equal to right-hand side value. Okay, So now I have my constraints, and I would like to make sure that these investments are non-negative, and I will use simplex linear programming to solve this problem. And hopefully you get this answer. All constraints and optimality conditions are satisfied. So I can create sensitivity report, click OK. So what's the result? The maximum return I can generate from my $100,000 is 8% or $8,000. How can I achieve that? I need to invest these amounts to each investment alternative. $20,000 to Atlantic Oil, $30,000 to Pacific Oil, no investment in Midwest Steel. Looks like it doesn't have that much a good return, or riskier than government bonds. I've invested $40,000 Hubbard Steel and $10,000 in government bonds. Let's take a look at that. All the constraints are satisfied. $100,000, I spend it all. $50,000 maximum, I use it all. $50,000 maximum steel investment, I did not invest all that 50,000. I just needed 40,000 to maximize my return. I was only allowed to invest up to $30,000 for Pacific. I use it all because it's a good return investment, highest. Government bond, oldest, lowest, since I want to have at least 25% of steel there, so I use $10,000. So this is a great application of mutual fund optimization model. That's it for this video. Enjoy business analytics.